So far, we've looked at this g of x example and have found that in total there is 4 roots. Now we saw from previous theorems that these roots could be real or complex, and we even saw some or all of the rational possibilities for these roots. But we can narrow that list down even further using Descartes' rule of signs. Descartes' rule of signs has us look at the coefficients of each term and look for sign changes between them. Here's how it goes. If we take a look at our polynomial, we see that we have a positive 2 in front of x to the 4th, a positive 7, a negative 8, a negative 14, and a positive 8. As we move from left to right, we see we go from positive to positive, and then we go from positive to negative. This represents one sign change. Next, we go from negative to negative, and then back from negative to positive. So we have 2 sign changes represented by the coefficients in our polynomial. That tells us the maximum number of positive roots. So of our 4 roots here, we know that we could have up to 2 positive roots. We can do the same with negative roots, but we have to change our equation just a little bit. If we take our g of x equation, and instead of finding the g of x, find the g of negative x, we can get a new polynomial function that we can use the sign rule for to find the possible number of negative roots. Let's see how that looks. So I'm going to rewrite the g of x equation, and instead of writing x, I'm going to plug in negative x everywhere. To simplify this, all we have to do is remember if we have an even exponent, it's going to make that negative with x positive. And so our first term will stay 2x to the 4th. But because we have an odd exponent in the second term, we're going to change the sign and will become negative 7x to the 3rd. Again, we have an even exponent, so our overall sign won't change. It will stay negative 8x squared. But here we're going to change to positive 14x. And so what we have now is a new equation for the g of x. Well, technically it's the g of negative x. And we have some new signs to consider. So let's use Descartes' rule and let's see how many negative roots we could possibly have. So we could have a positive here, negative here, negative here, positive here, positive here. So I see one sign change. Negative to negative is not a sign change. Negative back to positive is another sign change. And positive to positive is not. So I count 1, 2 total sign changes. And so of our total 4 roots that we have, we could possibly have 2 negative roots. And that's how Descartes' rule can help us when we're narrowing our list down. All right, so now it's time to put everything together. We learned earlier that because our polynomial had a degree of 4, we have 4 total roots. But we're not sure whether these roots are positive, negative, and complex. We just know they add up to 4. Well, Descartes' rule showed us that we could have up to 2 positive roots, up to 2 negative roots. And so if we think of a scenario here, let's call this scenario 1. If we had 2 positive roots and 2 negative roots, well, that would equal our 4 roots, meaning that we would have 0 complex roots in this scenario. To find other scenarios, we have to count down by 2 in our positive and negative roots. We can't count down by 1. And so if we count down by 2 in our positive roots, Well, our next possible amount of positive roots would be 0. Let's call this scenario 2. So if we had 0 positive roots, we could still have 2 negative roots, and that would leave us room to have 2 complex roots. Similarly, we could count down by 2 in our negative roots. So another possibility would be for us to have 0 negative roots. And that would leave us space to have 2 positive roots and 2 complex roots. Again, remember that these rows have to add up to 4, which they all do. We have one more possibility. Let's say that we have 0 positive roots, 0 negative roots. Well, that would leave us for 2 pairs of complex roots. Again, remember that complex roots have to come in pairs. That's why we have to count down by 2 in our positive and negative roots. And so these would be the only 4 scenarios that we could have for our zeros or our solutions to this polynomial function. In the next video, we'll look at how we can limit those positive or negative real roots that we found using the rational root theorem. See you there.